Hello, my amazing math students. This is Mrs. A, and I love math. Today, we're on lesson 73 in our Saxon Orange Book, and we're talking about factoring the difference of two squares. I especially like factoring the difference of two squares because it's so easy, and learning how to do it is so fast. So here are some examples of a difference of two squares. X squared minus y squared, 4p squared minus 25, m squared minus 16. And they're called the difference of two squares because x squared is a perfect square and y squared is a perfect square, and we're taking the difference between them. 4p squared is a perfect square and 25 is also, and we're taking the difference between them. So anytime you see a difference of two squares, it is always factorable into a sum and a difference. Let me show you how. Let's take the first one that was on my board, x squared minus y squared. If I take the square root of this one and the square root of this one, and I put them in two parentheses with a minus and a plus, guess what? When I FOIL this together, I get this. Let's try it. X times x is x squared. Remember, FOIL is first, outside, inside, last. Outside is positive xy. Inside is negative xy, and last is negative y squared. So what happens is that my positive xy and my negative xy cancel out, and I'm left with x squared minus y squared. So remember that anytime you have an x squared minus y squared, it means that your middle term has canceled out, and you have this situation. Now, just to remind you, we haven't done this in a while, my little hint for how to do FOIL. Let's just practice FOIL a little bit. FOIL, first, outside, inside, last. And I make a little foil man, okay? And my little foil man is a little Martian or something like that. He's an alien. He looks like an alien. But if you take the first and then you take the outside, you take the inside, you take the two last, doesn't he make a cool little Martian? Okay, so anytime you're thinking about foiling, you can remember the first makes an eyebrow, the outside makes his chin, the inside is right here by his nose, and it makes a smiley face, and then the other, the last, is his other eyebrow or cranium or something, whatever that is on the alien. Okay, so that's just a fun way to remember how to FOIL. But let's look at some more of our difference of two squares. Okay, so let's take the second one that was on the previous list, and let's do what I just said before. Let's take the square root of 4p squared, which would be 2p, and put that as the first in each one of my parentheses. Let's take the square root of 25, which is 5, and then let's put a plus and a minus. It does not matter where you put the plus and where you put the minus, but we're going to have one of each. Let's check it with FOIL. First is 4p squared. Outside is negative 10p. Inside is positive 10p. Last is negative 25. 4p squared, cancel, minus 25. Isn't that what I wanted it to wind up to be? So there is your, these are your factors, and this is the product that shows you we go back to what we wanted. Difference of two squares is pretty fun. Okay, let's do the next one. M squared minus 16. Take the square root of m squared and put it as the first part of each parenthesis. Take the square root of 16, which is 4, give one a plus, give the other one a minus. Those are your factors. Now let's FOIL to check. m squared. Outside is negative 4m. Inside, positive 4m. Last, negative 16. Cancel, cancel. M squared minus 16 is what we wanted it to be. So basically, isn't factoring the difference of two squares just a matter of recognizing that it's a difference of two squares? So we're going to recognize 9m squared is a perfect square. 49 is a perfect square. We have a difference between them. And we're going to take the square root of this one, 3m. The square root of 49, 7. Put our little parentheses in. Give one a plus, give one a minus, and we're done. So if we FOIL this, the 21m and the negative 21m cancel each other out, leaving us with what we wanted. All right, so a general pattern that we can follow. If we have the first thing squared minus the second thing squared, it's going to wind up being first plus second, first minus second, and it really doesn't matter. I could say first minus second, first plus second. It doesn't matter which order the plus and minus are in. There's your general pattern. Let's do some practice. Okay, so the first one is in the wrong order, isn't it? We usually start with x squared because we're going descending order of the power of the variable. So we're going to rewrite this x squared minus 4, and then we can recognize it as a difference of two squares. This is a perfect square. This is a perfect square. The square root of this one is x. The square root of this one is 2. Put in our little parentheses, add in a plus and a minus, and it's done. Okay, the second example is in a correct order. This is fine. The square root of this one is 7m. The square root of this one is a, plus, minus. Pretty easy. All right, so 2 more practices. This one is not looking real good right away because the minus is in the front. There's a plus in the middle, but what if we switch their order? And we get 25y squared minus 36a squared. Then don't they fit the pattern of a difference of two squares? The square root of this one is 5y. The square root of this one is 6a. Plus and minus, and we're done. Again, perfect square, minus in the wrong place. Let's just switch them around. 49a squared minus 36x to the 6y to the 4th. 49a squared is a perfect square of 7a. And 36, 6x cubed y squared, 6x cubed y squared, plus, minus. Those are really fun, aren't they? Okay, so we're still on lesson 73, but now we have our second topic, which is probability without replacement. Now, we just talked about probability after replacement. So we have 3 black marbles and 5 white marbles in an urn or some container. And if one is drawn and replaced, and then a second one is drawn, then what is the probability of black and black? In other words, both draws were black. Well, to do this problem, this is designated order, like we did a couple of lessons ago, and we have 3 out of 8 that are black, so 3 out of 8 would be the probability for the first draw, but then we threw that marble back in, and 3 out of 8 would be the probability for the second draw. So we would have 9 out of 64 would be the probability that both were black. However, what if we did not replace that one drawn and not replaced, and then a second marble is drawn. Does the probability for black stay the same if we keep a marble out? No, it can't stay the same. So in the second case, if we're doing probability of black and then black, for the first draw, the probability was 3/8. But for the second draw, there's one less black marble in there because we're assuming the first marble is black. So there's one less black marble and one less total of marbles. Okay, so wouldn't there only be 2 marbles after the first black marble was drawn? And would there still be 5, but there'd be 7 altogether? So 2/7 would be the probability of getting a black on the second draw after the first one was black and not replaced. Okay, so we would end up getting 6/56, or remember my 8's on the bottom, my 2's on the top, so 1/4. So 3/28 would be the probability of them both being black in the not replaced scenario. So look at that very carefully. Okay, we want to be able to do that. We ought to be able to change our answer depending on whether it's been replaced or whether it's not been replaced. Okay, so here we have another scenario. We have 4 red marbles and 7 blue marbles in the urn. Okay, so if you like, you can draw the scenario, and maybe since I've got a black marker, I'll just indicate colored and not colored. Okay, so I have 7 that are blue and 4 that are red in my little scenario here. And I'm looking for the probability of a red and then a blue with replacement. So with replacement means I'm going to draw one. I'm going to assume it's the one that I wanted. And I'm going to draw another one, assuming I put that one back in. Okay, so if I'm going to draw a red first, the probability of a red would be 4 out of 11 total. So 4 out of 11 would be my probability of a red. Now I'm replacing it back in there so that these stay the same. So I throw it back into the urn. Now what is my probability of drawing out a blue with all of the marbles back in there is 7 out of 11. So 7 out of 11, and I'll multiply those two together, and nothing will cancel, so I'll get 28 over 121. 11 times 11, 121. Now I'm going to do it without replacement. This one's not going to change. It's still going to be 4 over 11. But then I was drawing a red, therefore I take the red out because I assume I got a red and did not replace it. So now the probability of blue will be 7 out of 10. Okay, so on this one, my 4 and my 10 would simplify to a 2 and a 5. And nothing else will simplify, so I'm going to get 14 out of 55 for my probability of this scenario without replacement. These are a lot of fun too. So now we are done and ready to go to our practice problems. So get your paper ready. Okay, so here we are with A, B, and C. These are so quick, I decided to do them all on one board. Okay, perfect square minus perfect square. So no adjustment is needed. 8x, 8x, 9y, 9y, plus minus. Pretty easy. Okay, so now this one's not in the right form, is it? Because I have a plus in between them, but I do have a minus. So I'm going to just switch them around. 100 m squared minus 25. Square root of this one is 10m, and that's a 5, so plus 5. 10m minus 5. Okay, now look at this one. I could have done something before I did that one. I should have pulled out a greatest common factor of 25 first, but I didn't see it until I saw that I had factors in my factors. So this is right, but it's not completely factored because my factor has a factor. So let's fix that. Okay, so I'm going to pull out a 25 because it's a common factor, and I should always pull out common factors. 100m squared divided by 25 is 4m squared. And then the 25 gives me a 1. Still both perfect squares, aren't they? So it's going to be 25 times 2m plus 1, 2m minus 1. I almost missed that. We should always factor completely. And if I had a 10m minus 5, that factor has a factor in it. And I would lose some points, right? I would not have totally factored. So pull out your greatest common factor first. All right, so here, I think I messed that one up. Okay, so it is correct now. Okay, so it is in the right order. So we're going to take the square root of y to the 4th, x to the 2. And notice that there is no common factor. I'm not going to get bitten by that one again. Okay, so y squared x, y squared x, and the square root of 169 is 13. So 13z to the 5, 13z to the 5, plus and minus. Hopefully you can see that. I kind of ran out of space down there at the bottom. Okay, so here is problem D, and we're looking for purple and then purple. And we're going to do the first one with replacement. So we're talking about 2 draws. The first purple would be 4 out of a total of 7. So 4 over 7. But then we're going to replace that purple back into the urn. And so our probabilities will not change for the second draw. And we would have 16 over 49, excuse me. 16 over 49 would be the probability that I would get a purple and then another purple. Okay, and then without replacement, the first one stays the same. But then I keep that marble out and I am down 1 purple marble. I always assume I get what I wanted. I wanted a purple, therefore I assume I got a purple. So now I have 3 out of 6 total marbles left. So now we have some canceling we could do. The 3 and the 6 will cancel with a 1 and a 2. The 2 and the 4 will cancel with a 2. So we wind up with 2 7s. And that is D. We have one more problem. All right, so here we have our last problem. With replacement, without replacement, drawing 2 marbles, and we're looking for the probability of an orange and then a blue. So we're going to say, well, the probability of a first draw orange would be 5 out of a total of 11. So 5 out of 11. And guess what? Wouldn't that be 5 out of 11 right there? We don't even have to worry with it, do we? So now I'm going to throw that in, and I'm going to replace it. And then I'm looking for a blue. So blue would be 6 out of 11. So I'm done with the first one. There's nothing that can simplify. So it would be 30 over 121. The second one, though, I'm looking for a blue, but I did not replace the orange. So the orange is no longer there. So now I'm looking for a blue, 6 out of 10. Okay, so now I've got a 5 and a 10, which would be a 2 and a 1, and a 6 and a 2, which would be a 3. So I wind up with 3 11ths. And that is the end of your lesson. And this is Mrs. A, and may God bless your day.